Okay, guys, going a little bit off script here. So we have covered a decent amount of our acceleration stuff, but we have not done any questions that are graph related. And I know that I gave you some on the homework, and they are fair play for the exams or quizzes, so figured I would give you one. With this, I am playing it completely by ear. I don't know what I am going to draw yet even, so let's see how this goes. So I'm going to start and make sure that I leave space here. So I'm going to go ahead and go here, and I'm going to have a time axis, let's say in seconds, and I'm going to have an acceleration that is off the board. Didn't leave myself space. Acceleration in meters per second squared. And what we'll do is we will go ahead and start with that, and we are going to move that in, and I'm going to go down so that I've got space for my face here. And we will have time versus velocity. And we will, so that will go into this, and that's going to come back up into a time versus position. Time is going to be in seconds each time. Velocity will be in meters per second. And position will be in meters. Okay, so what do I want to do? Let's have something where we're going to have both positive and negative acceleration. So this is going to be 0. Let's do -1 and -2 here, and 1 and 2. And for this class, we will only have straight lines for acceleration. So let's go ahead and say that we are going to start an acceleration of 0 for my first second. So I've got my line in there. So 1 second with no acceleration, and then we are going to jump up and be at 2 meters per second for a second. We're going to jump down and be at 0 meters per second for a second, and then we'll jump down and be at -2 meters per second for a second. Okay? So moving this into the velocity graph. I do not currently have enough information to do that. So the one thing that I'm missing is I don't know what velocity I am starting at. So let's say that I am starting at time equals 0. So this is still 0, 1, 2, 3, 4. I'm just going to put a note over here because I don't know what the axes are because I'm making it up as I go. My velocity is going to be equal to -1 meter per second. We might have some weird fractions in here. I am sorry. So velocity at time 0 is -1 meters per second. So that means that my velocity at time 1 is still going to be that, because velocity final, or in this case, velocity at 1 is going to be equal to velocity at 0 plus acceleration times time. Velocity at 0 is -1. Acceleration is 0. So the fact that it is 1 second doesn't really matter because we're multiplying by 0. So my velocity at 1 is going to be -1. Velocity at 1 is equal to -1 meters per second. And that is off the board. I apologize. I'm going to move all this up then. Velocity 0 is equal to -1 meter per second. Velocity 1 is equal to -1 meters per second. Okay. Velocity at time 2. Velocity at 2 is going to be equal to velocity at 1 plus acceleration times time. Perfect. We can now say that velocity at 2 is going to be, velocity at 1 is -1. Acceleration is constant. It's 2 for that entire thing. We can only use this equation if acceleration is constant. So that is good. 2 times time, which is going to be 2 seconds minus 1 second. So that's 1. So this is a velocity of 1 meter per second. Perfect. So velocity at 2 is equal to 1 meter per second. Hopefully we can see that velocity at 3 is still going to be 1 meter per second because we have no acceleration there. Which leaves velocity at 4. Velocity at 4 is going to be equal to velocity at 3 plus acceleration times time. My acceleration is -2 over this. I've still got a 1 second time change, and I'm starting at 1. 1 minus 2 is going to be that velocity 4 is back to -1 meter per second. Whew. Okay. So I can now draw this. And it looks like I only need from -1 to 1. So I'm going to go ahead and put my dashed line here. This is going to be my 0. I will have -1 meters per second up here and 1 meter per second right there. So velocity at time 0 is -1. Velocity at time 1 is -1. Velocity at time 2 is 1. Velocity at time 3 is 1. Velocity at time 4 is -1. Hopefully this isn't too similar to your homework, but we have constant acceleration, which just like with our previous one, we have if we've got constant acceleration, just like when we had constant velocity, we had all straight lines in the position one. If we have constant acceleration, flat acceleration is going to become a straight line in the velocity plane. So all of these lines end up being perfectly straight. And that is my piece. Now again, just like with our position ones, we can do this very easily by just looking at the area under the curve. So we have 0 from 0 to 1. So we've got a slope of 0 because there's no change. We have no change here. We have an increase of 2. We have, area under the curve is 0, no change. We have area under the curve of 2, we increase by 2. We have an area under the curve of 0, we increase by 0. We have an area under the curve of -2, we decrease by 2. So just the same as what we were doing. If this were velocity and this were position, it would be true nonetheless. However, we now have the step velocity to position, and once again, we need something before we can start this. So we will say that at time 0, my position is 2. Yeah, we'll call it 2. Our position is 2 meters. So our first piece we have right here, we can say that x1 is equal to x0 plus v naught t plus 1/2 at squared. My acceleration between 0 and 1 is 0. So this is 0. My velocity between 0 and 1 is -1. So I've got -1 times my time, which is between 0 and 1 is 1 second. And my position 0 is 2. So x1 is equal to 2 plus -1, which is just going to be 1. So x at time 1 is 1. Perfect. And I'm going to save myself a little bit of writing. Next step, between 1 and 2. So I have x2 is equal to x1 plus v1t plus 1/2 at squared. Same equation we've been using like crazy. x1 is 1. We just found that. v1 is -1. I've got a change in time of 1 second because I'm going from 1 to 2 seconds. That's a change in time of 1 second. Plus 1/2 times my acceleration. Well, my acceleration between 1 and 2 is 2. And change in time is 1 second squared. So I've got 1 plus, 1 plus -1, which is 0, plus 1/2 times 2. So that is x2 is equal to 1. Easy enough. Continuing our piece. Our position at 3 is going to be dependent upon our position at 2. We have x2 is 1. Velocity at time 2 is 1. Change in time of 1 second plus 1/2. Acceleration between 2 and 3 is 0 times 1 squared. That entire thing goes to 0. x3 becomes 2. And trying to go as fast as I can here. x4 is dependent upon 3. Easy enough. x4 is going to be x3, which is going to be 2, plus my velocity at that time. Velocity at time 3 is 1 times 1 plus 1/2 times my acceleration is -2 times 1 squared. So 2 plus 1 times 1 is 1. 1/2 times -2 is -1. So x4 is still equal to 2. Okay. I now know my parameters. So I am staying positive. So I've got 0, I've got time 1, 2, 3, 4, and we will do 1, 2, 3. My position at time 0 is 2. My position at time 1 is 1. My position at time 2 is 1. My position at time 3 is 2. And my position at time 4 is 2. I can't just draw straight lines now, though. I can for a couple of them. Between 0 and 1 second, I have a flat line. It's going -1. It is a constant acceleration. I am going straight line. And between 2 and 3, I have a constant acceleration. I can draw a straight line. However, between 1 and 2 is not a straight line, because what's happening is I have a change in velocity. Anytime velocity is changing, you're going to have some form of curvature in position. If we did anything with non-constant acceleration, you would have a curvature in velocity anytime acceleration was not a flat line, was not constant. So what's it going to look like? For this, what I'm going to do is I'm actually going to go back to the other way of doing this for a second. Velocity under the curve that area is -1, correct? Because we've got distance of 1, we've got a distance of -1, we have an area of -1, so we went down 1 in the position. I now have this piece here. The overall area of this piece is 0, because these two triangles are exactly the same. These two, this guy and this guy. Completely identical, except one is above the 0 axis, so it's positive, one is below. So I'm going to go ahead and break this into time 1.5. So now I'm going to take this triangle at time 1.5, and we're going to draw it out here. So at time 1.5, this is at 0. At time of 1, this is at -1. So this side length is -1. And this is at time of 1, and this is at time of 1.5. So this guy is 1/2. So the area of a triangle is going to be base times height. Oops, this isn't negative. Divided by 2, because it's half of a rectangle. So this is 1/4. So this is -1/4. And this piece would then be, so this is -1/4. I can write it right here, and this is +1/4. So overall it's 0, but it's those two pieces, and it looks a little bit better when I'm not behind it. So there is a change. So if I look at time 1.5, it's going to be down 1/4. So this is 3/4, and there's going to be a dot right there. Okay? And this area at the beginning, just like we talked with on the first day, this area is bigger than the second area. So it's going to be going down faster and then leveling off. And then when we look at the inverse, if I look at this guy, this area is smaller than this one, so it's going to go up slowly and then accelerate. So you get a little bit of a loop right there. And the same thing is happening between 3 and 4. With this negative acceleration, you're going to get a little bit of a loop right here. And you probably saw something like this going from here to here on your other piece. It's going to be more common when we have acceleration, because if you have acceleration, it means that you have these lines. So that is the off-the-cuff version of how to do these graphs when we're talking about acceleration. Hopefully it was helpful to you.